Okay, in this video we're going to look at taking derivatives of some trigonometric functions. We've looked at taking derivatives of sine and cosine in a previous class. We found the derivative of sine was cosine, derivative of cosine was the negative of sine. In this class we're going to take the derivative of tan. Now this is also standard derivative. This is actually listed in your formula and tables booklets, but we're going to take the derivative using what we know already, but from now on you can just use that standard derivative, and then we'll take the derivative of some composite functions known as sine of 2x minus 3, composed of the sine function and the function 2x minus 3, cosine squared of something. Okay, so let's start with this tan of x. I want to take the derivative of f of x equals tan of x with respect to x. So it says differentiate. Remember, the process of finding the derivative is called differentiation, and it's with respect to x, which is the variable included in the function. So I'm taking the derivative with respect to x of f of x. So derivative with respect to x, f of x in this case is tan of x. Now, the derivative of f of x, we know we call that f prime of x. That's a nice bit of notation we use. F prime of x is equal to the derivative with respect to x of, well, tan of x. We have an identity for tan of x. We know, again, from previous work that sine of x over cosine of x is always equal to tan of x. And we've just, in our previous class, we've actually found the derivatives of sine and cosine, so this is useful. Also, we know from previous work something called the quotient rule. And the quotient rule says to take the derivative of a fraction, it's the bottom, cosine of x, times the derivative of the top. Now, the derivative of sine of x, we found out, was cosine of x, minus the top, sine of x, times the derivative of the bottom. And again, in the previous class, we found the derivative of cosine of x as negative sine of x, all over the bottom squared, which is cosine of x squared, which we call cosine squared of x. Now we can simplify that fraction. On top, cosine by cosine, we call that cosine squared. So we've got cosine squared of x. We also have a negative by a negative, giving me a positive. And then sine by sine, giving me sine squared of x, all over cosine squared of x. Here's our working identities coming in useful here. On the top, actually, we have the Pythagorean identity from previous work. We know that cosine squared of any angle plus sine squared of the same angle is equal to 1. So that's 1 over cosine squared of x. And 1 over cosine squared of x is also known as secant squared of x, because secant is the derivative of, secant is the reciprocal of cosine. So therefore, f prime of x is equal to secant squared of x. So the derivative of tan of x is secant squared of x. Notice that's also a standard derivative on page 25 of your formula and tables booklets. See if you can find it. In this case, we did it from scratch. That's why it is secant squared of x. Let's look at taking the derivative of the second function there on my left, which is y equals sine of 2x minus 3. Y is equal to the sine of 2x minus 3. And I want to take the derivative with respect to x. Now, the derivative of y with respect to x we call dy dx. There's our Leibniz notation in this case, as opposed to our function notation. And what I've got to be able to see is this is actually a composite function. The outside function is sine, the inside function is 2x minus 3. The derivative of sine of blob is cosine of blob multiplied by the derivative of blob. Okay, blob in this case is 2x minus 3. So one more step here to find the derivative. The derivative of 2x minus 3, I'm hoping you can see that's just 2. So we'll get 2 multiplied by cosine of 2x minus 3. That's the derivative of sine of 2x minus 3. So dy dx is equal to that. If y is equal to sine of 2x minus 3, then dy dx is 2 cosine 2x minus 3. We had to use the chain rule here. So important that you're up to speed on all your different rules. Let's look at the last example here in my list. It says take the derivative with respect to x of g of x equals cosine squared of x cubed minus 2x plus 3. Bit of function notation here. Let me write it down. G of x equals cosine squared of x cubed subtract 2x plus 3. And I want to take the derivative with respect to x of this function. Take the derivative on both sides. The derivative of g of x with respect to x, well, that is called g prime of x. And what I'm going to do here is I'm going to take the derivative, but cosine squared, one thing about cosine squared, what does cosine squared mean? Well, it means cosine of the function, cosine of x cubed, minus, sorry, not plus, minus 2x plus 3. Cosine squared means that whole thing squared. So really we're taking this derivative, the square of cosine of this thing. This is a composite function. It's the square of the cosine function, the cosine of this. So there's a few different things in here to take the derivative. The outside function is something squared, blob squared. The derivative of blob squared is twice blob to the power of 1 times the derivative of whatever blob is. Well, in this case, blob was cosine of x cubed minus 2x plus 3. Now we have to take the derivative of cosine of x cubed minus 2x plus 3. Notice that's the chain rule. You got to know your chain rule. So what I get here is, well, that's just 2 times cosine of x cubed minus 2x plus 3. But now I have to take a further derivative. And again, notice it's cosine of a big long function. This is a composite function, a function within a function. The outside function here is cosine. The derivative of cosine is sine of blob times the derivative of whatever blob is. Notice chain rule a second time. Derivative of sine of blob. Well, blob is the inside part of the function, x cubed minus 2x plus 3. And then we have to take the derivative of that, x cubed minus 2x plus 3. So chain rule, this is why it's called the chain rule. It's, chain. It's a chain of events that leads to a final kind of answer. So now we're taking the derivative here of this thing. The derivative of this thing will be 3x squared. So we're going to get all this same stuff at the start. 2 cosine of x cubed minus 2x plus 3 multiplied by sine of x cubed minus 2x plus 3 all times the derivative of x cubed minus 2x plus 3, which would be 3x squared minus 2. And one thing I can do to simplify this a little bit more is I can just multiply that 2 by this function here. So I would write that as 6x squared minus 4, 2 times 3x squared minus 2. Put in a bracket times cosine of x cubed minus 2x plus 3 times sine of x cubed minus 2x plus 3. So that's quite long-winded, but it's a chain rule thing. You got to be able to use the chain rule. You got to know it and how to use it, the chain rule. So that's how we take the derivative of that function. So those are derivatives of trigonometric functions. Practice, practice, practice.